Hello and welcome to day 2. So we are just continuing on learning about the remainder and factor theorem. So, sorry about that. We are going to look at this first problem here. So factor f of x equals 3x cubed plus 13x squared plus 2x minus 8. Given that f of negative 4 equals 0. So, ignoring this whole second part here, if we were to see this and it told us to factor, our gut response should be to factor by grouping because we have 4 different terms here. So when we have 4 terms, we should think factor by grouping or the Bruce Wayne method. However, whichever way is more fun for you. Okay, so when we do that, we'll factor the first two, take out the GCF. So when we do that, we'll have we'll have an x squared, and we'll be left with 3x plus 13, and that's when we factor out a 2, we'll get x minus 4. When we factor by grouping, these should be the same, but they're not. So factor by grouping does not work here. So we put a little sad face, cannot factor, because we're sad. But we can have another alternative. This is why it gave us, given that our f of negative 4 equals 0. What that is helping us to see, when it gives us this, what that wants us to think about is that x equals negative 4, that is a solution. Okay, when it's a solution, that means it's a x-intercept, and so in this, we go over, this gives us the point negative 4, 0, so that gives us the value of negative 4 as a solution. If we were to take that and try to write that as a factor, we'd add over the 4, we'd have x plus 4 equal to 0, which means that x plus 4, that is a factor. Okay, you should be able to go from writing it as a solution, writing it as a factor, either way. So that was just a little practice, but a way that we should know after yesterday is taking our number that we got as a solution and looking at our polynomial and doing synthetic division. Okay, so let's do that. Our negative 4 is going to be on the outside, and let's draw our synthetic division bar. And looking at this, we have a cubed, squared, first, and 0 power, so we're all good there. We are not missing any terms. So let's just write in our coefficients of 3, 13, 2, and negative 8. So the first step is to bring down this 3. Then we say negative 4 times 3, that's a negative 12. We add these two together to give us a 1. Negative 4 times 1 is negative 4. We add those two to give us negative 2. Negative 4 times negative 2 is a positive 8. Add those together, and we end up with 0. Now, this is really key. If we end up with the 0 here, that means we have no remainder. And another thing, if we don't have a remainder, that means when we divided this whole f of x, when we divided that by our factor of x plus 4, that means that it went in perfectly. That means we didn't, like when if we were dividing two numbers and came up perfectly, we don't have any decimals, that number goes into that larger number perfectly. Same here, this x plus 4, that goes into this whole factor perfectly, no remainder. So that means it is a factor. Okay, that means this x plus 4 is a factor of this polynomial. Okay, I mean, it already told us that up here. That's what this hint was. But this no remainder, that confirms it. Okay, so we know that our x plus 4 is a factor. So if we were to start writing our equation over here in our factored form, just starting it out, we know for sure we'll have f of x equals, we know for sure we're going to have an x plus 4. Okay, but as of right now, looking back over here at our synthetic division, if we started off with an x to the third power divided by an x. That means this is going to be our x squared, so we'll have 3x squared, and we are adding an x and subtracting a 2. So then from here we have to think, okay, well, can I factor this even more? Because that's what our original instructions were just to factor this. So we can't factor our x plus 4 anymore, but let's see if we can factor our 3x squared plus x minus 2. So this is just, excuse me. So this is just our normal quadratic, but since our a value is greater than 1, we're going to have to use our Batman method. So we have to think what two numbers multiply to be negative 6 and add to be 1. We bring down our 3x squared and our negative 2 here. So two numbers that satisfy this is a positive 3x and a negative 2x. Okay, so then now we just factor by grouping, the Bruce Wayne method. So factor out a 3x, that leaves us with a x plus 1, and then out of the second term we can factor out a negative 2, which is with x plus 1. Oops, and now we have a common term here, and that's what we want, what we didn't have before. So now we're left with a 3x minus 2 and an x plus 1. Okay, so those are our next two factors. We can't simplify those anymore. So now I'm going to move them over to our factored form, but I didn't leave enough room. So I'm going to write it down here. You may have enough room, so you may have been able to write it. So we have our f of x equals x plus 4. And then we have our 3x minus 2 and our x plus 1. Okay, and that's all it asks us to do, is just to factor this. Okay, so this is our factored form. Don't forget your f of x here. That's a key mistake people make, but this is our final answer. Okay, moving on to the second part, finding zeros of a polynomial function. So it says, how many solutions should you expect to find? Now this we can figure out by looking at our degree. So looking at our degree of our polynomial here is 3. And if you want to write yourself a note, you have to look at the degree. Remember, the degree is the largest variable in your polynomial. Variable exponent, I mean. So that would be 3 here. And that helps you because when you go to factor, it just helps you to say, okay, well, I'm going to be looking for 3 zeros after I factor this. So I should get 3 answers out of this. So if I don't, then that helps me to remember to go back and check my work to make sure that I get 3. Okay? So 1 0, another word for that is root or solution of this polynomial is negative 5. So it's telling us our solution right off the bat, and it says find the other zeros of the function. So a way to do this, the easiest way, is synthetic division. So we have our negative 5 on the outside, have our synthetic division bar, and then we check our polynomial. Do we have any missing terms? 3, 2, 1, 0. No, we are good. So we write our coefficients at the top, 1, 6, 3, and negative 10. And here we go. Let's try to simplify this to find our other zeros. So we bring down the 1. Negative 5 times 1 is negative 5. Add these two to get 1. Negative 5 times 1 is negative 5. Add these two together to get negative 2. Negative 5 times negative 2 is a positive 10. Add these two together and you get 0. So this just confirms our negative 5 here. That is a solution. And now these numbers give us our equation of x squared plus x minus 2. We started off with an x. When we divide by a solution or just an x, we're going to get x squared. So then from here we have to think, well, can we factor this? Can we simplify this at all? Okay. Well, looking at this, well, we can factor this. Just like a normal quadratic, we say what two numbers multiply to be negative 2, but add to be a positive 1. And that gives us x plus 2 and x minus 1. Okay, so if we look at all of our factors that we have so far, we have these two, and then we have this factor up here of x plus 5. Okay, so let's look at our factored form. That would be our f of x. And then all of our factors just being pushed together. So we have x plus 5 multiplied by x plus 2 and x minus 1. So from here, if we read the directions, it wants us to find the other zeros. So we can't just stop at this factored form, we have to find the other zeros. To do that, all we do is we set this f of x, this whole polynomial, equal to 0. When we do that, we need to use our zero product property and set each of these factors equal to 0. So I'm going to rewrite that. So when we do this, all we're doing is we're solving for our x. So then we'll get an x equals negative 5, an x equals negative 2, and an x equals 1. So these are our zeros of our polynomial. Okay? And let's flip the page over to our last problem here. It says 1, 0 of f of x equals x cubed plus 3x squared minus 7x minus 6 equals x equals negative 2. Find the other zeros of the function. So just like we did last time, I want you to use synthetic division to simplify this polynomial, but first pause this video, try it on your own, and then compare with what I have. Okay, so once you use synthetic division, you should get x squared plus 5x plus 3. If you did not get that, pause the video and check your work again and compare with what I have. So from this step, we know we have one factor of x minus 2, but let's see, we're going to have to see if we can factor this. Well, sometimes we can, sometimes we can't, and in this case, it does not factor. Sad face. So let's write out what we have so far, because this doesn't stop us from writing it in factored form, because this whole thing is still a factor. So we have our f of x that equals our x minus 2, and that is being multiplied by x squared plus 5x plus 3. Now, again, we want to find the other zeros, just like last time. So we're saying this whole thing equal to 0, so we'll have x minus 2 times x plus 5x plus 3. That whole thing is equal to 0. So again, zero product property. We set our x minus 2 equal to 0, and we set our x squared plus 5x plus 3 equal to 0. Our left one's real easy. We get x equal 2. Boom, we're done. But we got to try this one on the right. Now, if we can't factor it, we have to think about all the other ways we know how to solve a quadratic. And if we can't factor it, one of the other ways that we can use is our quadratic formula. So if we remember, our a is 1, our b here is 5, our c is 3, and our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c all over the value of 2 times a. Okay, so when we simplify this, we get negative 5 plus or minus the square root. This is 25 minus our 12, which gives us 13. That's all over 2. I'm going to rewrite this. That's a very big square root. So then from here, depending on what our answer says, if it says exact answer or rounded answer, we might be able to leave our answer like this. And what this represents is one of our zeros. Our x equals negative 5 plus root 13 over 2 and negative 5 minus root 13 over 2. Now if we wanted an exact answer, that would be x equals 2 and negative 5 plus or minus root 13 over 2. But if we wanted a rounded answer, we might get something different. We would get negative 0.70, negative 4.3. So I would at this point check in your calculator if you know how to put this in correctly. Make sure you put parentheses around the top to see if you can get to these rounded answers. And we're done.